Hi, I'm Josh Horstman, and today we're going to talk about SAS macro variable lists. Originally, this was supposed to be a hands-on workshop to be presented at the SAS Global Forum 2020 conference in Washington, D.C. Sadly, the conference had to be canceled, and so we weren't able to meet there together. But we can still learn about SAS macro variable lists through this online format. I would encourage you to download the exercise files. There are 8 exercises, and we'll go through them one by one as we move through this material. So fire up your SAS software, and let's talk about macro variable lists. Now, what do we mean by a macro variable list anyway? Well, first of all, a macro variable list is just a way of using macro variables. It's not a specific language element that exists in SAS. You won't find it in the SAS documentation. It's just a technique that we can make use of macro variables to our advantage. Basically, we're going to use macro variables to store a series of values, and we're going to do it dynamically. That is, the values are going to come from our data, and they won't be hard-coded into our program. They'll be determined at runtime based on what comes in to our program. This will allow us to build programs that are more dynamic. In other words, they adapt and respond based on the data. Their logic is driven by that data as opposed to having a bunch of things hard-coded. And so we eliminate these hard-coded data dependencies, which means we don't have to change our program every time our data changes. That saves us work and makes our code easier to reuse and more flexible. It also lets us include lots and lots of ampersands in our code so we can confuse our coworkers and make sure they'll have to keep us around for years to come in order to maintain this code. Just kidding about that last part. Here's a little outline of what we're going to go through today. First of all, we'll do a little short review of the macro language. Now, I'm going to assume that you are familiar with the macro language, at least how it works at a fundamental level. If you're completely new to the macro language, you probably would want to go learn a little bit more about that before you proceed with this lesson, because we're going to assume that you know some of that. So go watch some other videos. There's plenty out there on YouTube or on SAS support channels, or get Art Carpenter's excellent book on the macro language and find out all about it. But we'll cover the basics just to refresh your memory in case it's been a little while. Then we'll talk about creating macro variable lists, and specifically we'll talk about how to create them using PROC SQL, and we'll talk about how to create them using a data step. 2 different methods with the same outcome, and we'll talk about why you might want to use one or the other in a certain situation. And then we'll talk about actually using these macro variable lists to do something useful. And as you can see, we'll go through 8 exercises over the course of these topics. With that, let's dig into our macro language review. We'll start by talking about how macro processing works. What happens when you submit some SAS code? Well, the first thing that happens is the code is scanned by the word scanner and parsed into tokens. Tokens simply means little bits and pieces of SAS language, the various language elements, the bits of syntax, such as variable names or keywords or operators, things like that. Those are tokens. And then those tokens are sent to the compiler for syntax checking to make sure that the tokens that you've put together and the order in which you put them together constitute valid SAS syntax. And only once that has been checked is that SAS code executed. Now, when the word scanner detects a macro trigger, something different has to happen. Macro triggers typically start with a %sign or an ampersand. Not every %sign or ampersand is a macro trigger. Sometimes those have other meanings in SAS, but most macro language triggers do start with those characters. So when we find one of those macro triggers, the word scanner routes those elements to the macro processor. So this is a bit of an intervention. Before SAS gets the code to execute, the macro processor steps in to do some stuff. Specifically, it resolves macro variables that you may have referenced in your code, and it executes macro statements. Those are things like %if, or %do, or %let. And once it finishes with that processing, some output results from that, and that output has to be rescanned Whatever is produced by the macro processor is rescanned to see if there are additional macro language triggers in it, and additional processing is needed, because your macro code could generate more macro code, and we're going to see an example of that later in this talk. Here's a diagram that might be helpful for explaining this. Now, this diagram came from Art Carpenter's excellent book, A Carpenter's Complete Guide to the SAS Macro Language, and I think it's pretty helpful. As you can see here, we submit our SAS code at the top left of the diagram, and this is sort of a flowchart representation. So we go down and say, does it contain macro references? That's the % and ampersand triggers. If it does, the macro facility is invoked, macro references are resolved, so that could be references to macro variables or entire macros, and then macro statements are executed, and then that results in potentially some additional code. Now, what comes out of there may just be pure SAS code, because after all, the macro language is a SAS code generator. That's what it does, right? It generates SAS code. And if that's what it contains, then it won't have any more macro language references. So the answer to this question will be no. And then that step, meaning the data step or PROC that we just submitted, will be compiled, parsed, and executed in the normal way. However, if that text that came out of the macro processor has additional macro references in it, then this loop must repeat. And this can repeat as many times as necessary in order to resolve all of the macro references and execute all the macro statements until we're left with nothing but pure text. Now, as far as the macro processor is concerned, everything is either a macro language element or text. The macro processor doesn't actually care whether the text that it produces is valid SAS code or not. The macro processor will produce the text, and then if it's not valid SAS code, SAS will complain about that, but the macro processor won't. The macro processor will simply do what it's told until it has removed all macro references. It's important to understand when each of these different events happens, because understanding the timing of various parts of macro processing can help us avoid some problems that we're going to talk about in a few minutes. Let's talk about creating macro variables using the %let macro statement. As most of you probably know, we can create a macro variable by simply saying %let the name of the macro variable that we wish to create equals, and then the value we wish to assign to that macro variable. And when this statement is executed by the macro processor, it will take that value and store it on the symbol table. The symbol table is where macro variables are stored. So this statement here will create a macro variable called output_path, and it will store the value C:\temp in that macro variable. Later, we can refer to that macro variable using the ampersand notation. So for example, here we have a file name statement. File name, my file, and then in quotes, where we normally would have a complete path and file name, we have a macro variable reference. We have ampersand output_path / myfile.txt. When this statement is submitted, the macro processor, well, the word scanner will notice that there's a macro trigger in here, and the macro processor will then kick in and resolve this macro variable reference. So the macro processor, it doesn't care about file name, my file, those just pass on through, but then it sees ampersand output_path and says, that's a macro variable reference. I need to go check the symbol table, find out what value that macro variable has, and replace that reference with that value from the symbol table. So it goes to the symbol table and finds C:\temp, and that value is placed into the input buffer instead of ampersand output_path. So now we have file name, my file, and then C:\temp / myfile.txt. That is what actually gets passed on down to SAS for execution. The macro processor stepped in, did its job of replacing the macro variable reference with ordinary text, and then finding no more macro variable references, it sent what was left down to SAS for execution. Now, there's a problem that we have to talk about that we can come across when we're using %let. And this has to do with the timing that we discussed a minute ago. %let is a statement that's executed by the macro processor. That means that it executes before SAS compiles and executes the SAS code. So let's look at this data step here. We have data null, set sashelp.class. Now, that's one of the built-in data sets that comes with SAS. There's a whole library called sashelp. Sashelp.class has 19 records with information about the kids in a grade school classroom. And one of those kids' names is Alfred, and so we've said where name equals Alfred, so this is only going to read in one record. So we read in the one record where name is Alfred, and now we have %let, and we attempt to create a macro variable called Alfred underscore age. %let Alfred underscore age equals age. Age is the name of one of the variables in the sashelp.class dataset. So we read in one record, and then we attempt to take the value of the variable age and assign it to a macro variable called Alfred underscore age. That should work, right? Well, this is not going to come out the way we were hoping. Here's what happens. When we submit this code, it goes to the macro processor first. The macro processor sees all of this text, data null, set, sashelp.class, blah, 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 blah. It just passes that on through until it gets to %let. There's a macro language trigger. %let Alfred underscore age equals age. And it literally assigns the letters AGE, that string, to a macro variable called Alfred underscore age. Right? It doesn't see that as a variable name because at this point in time, the data set hasn't even started executing yet. At this point in time, we're still just in the macro processing loop, that loop at the top of the diagram that we showed a few slides ago. And so it replaces, it assigns that macro variable, and then it gets to run, and then sends all the rest of this code down to SAS, and all the SAS compiler sees is data underscore null underscore set sashelp.class where name equals Alfred. Run. That's it. So the macro variable is going to contain the value AGE. It's not going to contain the actual age that came from the data set. Because of the timing of when %let runs, we can't actually use it to get values from our data set into a macro variable. So how can we get values from our data into a macro variable? Well, one way is by using a routine called simputx. Now in SAS, routines are sort of like functions, except they don't return a value, and the way you invoke them is using the call syntax. So we usually see call simputx. So here we have the same data step that we had on the last slide. However, instead of a %let statement, I have replaced that with call simputx, and then call simputx has a couple of arguments. The first argument is the name of the macro variable that we wish to create. And it's in quotes because we've provided a literal string. So Alfred underscore age. If I didn't put the quotes around it, it would think that was a dataset variable that I was attempting to take the value from. So the macro variable is Alfred underscore age, and then the value that I wish to put into that macro variable is the value that's in the variable age. Well, as we discussed before, there's only one record read in here because there's only one record that satisfies this where statement. So the value of age that comes in with this record is stored in the dataset variable age, and then when call simputx executes, that value is placed into the macro variable Alfred underscore age. The key to remember here is that call simputx executes at data step execution time. It's not actually a macro language statement. It's a data step statement. It puts a value on the symbol table, which is where macro variables are stored, but it's not part of the macro language itself. So because of that, it executes during data step execution after all the macro variables and macro references have been resolved, and after the data step has compiled and begun executing and data has been read in. So at this point in time, we do have access to our data, and we can use this method to store data values in a macro variable. And in this case, the value that's read in will be 14. That's the value of age for that record in that data set. And that's what will be stored in the macro variable called Alfred underscore age. Now this brings us to our first exercise. In exercise 1, we will create a simple macro variable at execution time using a data step. We'll be working with the sashelp.cars dataset, which is one of the example datasets that comes with SAS. And our task is to use the call simplex routine to place the MSRP, that is the manufacturer's suggested retail price, for an accurate MDX into a macro variable called MDX_price. The code is partially written for you. There's a data step here with a set statement that reads from sashelp.cars and a where statement that will subset that data set to read in just the one record that pertains to the accurate MDX. All you have to do is add a call simplex statement that will take the MSRP, and by the way, that's the name of the variable, MSRP, take the value of MSRP and place it into a macro variable called MDX_price. So at this point, if you would like, you can pause the video, open up your SAS session, load the exercise 1 file where you should find this code, and then you can replace this comment with an actual call simplex statement to complete this task. I'll go ahead and do it here on the video, and there's also a solution file that is included with the workshop files that shows one way you could complete this task. Let's open up our SAS session and we will work through exercise number 1 together. Alright, I have the exercise number 1 workshop file open. We need to replace this comment here with a call simplex statement that will create the macro variable that we need. So let me delete the comment. And we will type call simplex. And the first argument to call simplex is the name of the macro variable that we want to create. In that case, it will be MDX_price. And then the second argument is the value that we want to assign to that macro variable. In this case, we want to assign the value from the dataset variable MSRP, which was read in from sashelp.cars. MSRP. All right, and you'll notice at the bottom of the code file here, there's a little bit of extra code that just verifies the value of this macro variable. Because if all we did was run this data step, we wouldn't actually see anything happen. We wouldn't be able to verify that this macro variable had been created. So in order to do that, we have some %put statements, which will write this message to the log, the MSRP for an accurate MDX is, and then it will pull the value of MDX_price. By the way, why are there 2 periods here? Well, one period is to tell the macro processor that this is the end of the macro variable reference, and the second one is just an actual period that will appear in the log. If I just put 1 period there, then that would be taken as the end of the macro variable reference, and it wouldn't actually, there wouldn't be 1 in the log as well. Since I wanted 1 in the log, I have to put 2. So let's run this code, and let's look at our log. And here we see in our log, it did work. In fact, our data step ran. 1 observation was read from sashelp.cars. That was the observation for the accurate MDX. And then the value of MSRP was stored in the macro variable that we wanted, and here it is, 36945. Now there's a little bonus exercise here. What happens if a %let statement is used instead of a call simplex statement? We talked about this a little bit earlier when we were using the sashelp.class example. But let's do it anyway, just to remind ourselves what happens. Let's suppose instead of call simplex, I said %let MDX_price equals MSRP. Recall that when this code is submitted, the macro processor is going to get a hold of this %let first before any data step has begun executing. It will assign the letters MSRP to the macro variable MDX_price, and that will be the value of that macro variable. Then the data step will run the rest of these statements, but of course this won't be there anymore since it will have been consumed by the macro processor. So if we run this code and then check our log, you'll notice we have the MSRP for an accurate MDX is MSRP. Clearly that's not the result that we wanted or expected, and that is because of this %let statement. Let's take another look at that macro processing diagram. The %let statement executes here during the macro processing phase. At that point in the process, the data step has not yet begun executing, nor have any data been read in. The call synputx statement executes down here during data step execution, after the macro processor has already finished its work, and then the data step has been compiled and started executing. That's why the call synputx lets us get at that value from our data, from the sashelp.cars dataset in this example, whereas the %let does not have access to that because it happens too early. So it's key to understand what happens when. Another way we can create a macro variable at execution time is using PROC SQL. Just like we used call synputx in the data step to do this, we can use PROC SQL to do this. And we do that using the into clause. Now the into clause is not a part of the ANSI SQL standard that exists outside of SAS, but it's something that SAS has added on to the SQL language in order to interact with macro variables. The syntax is quite simple. We simply insert it into our select statement, select age. Age is the variable that we're going to select, in this case from sashelp.class, but we select it into a macro variable that we're going to create called Alfred_age, and we have to precede that name with a colon. That's how the syntax works. So we select age into AlfredAge from sashelp.class where name equals Alfred. And as you may recall from earlier, this only selects one record. So one value gets selected and it is stored in this macro variable Alfred_age. And it will have the value of 14 just like it did when we used call synputx in the data step earlier. For our second exercise, we're going to create a simple macro variable at execution time, this time using PROC SQL. Once again, we're working with the sashelp.cars dataset, but this time we'll be looking to get the value of weight for the accurate MDX and place it into a macro variable called MDX_weight, and we'll use that into clause from PROC SQL. You'll see that we're provided with some PROC SQL code. All we have to do is complete the select clause here and store the value of weight into a macro variable called MDX_weight. Let's switch over to our SAS session. I have the exercise file for exercise 2 open here. So here is our select statement. I'm going to remove this comment and I'm going to say select weight. That's the name of the variable in the dataset sashelp.cars that I want to store in my macro variable into MDX_weight. That's the name of the macro variable that I wish to create. Select weight into :MDX_weight from sashelp.cars, and then I have my where statement that gets the record for accurate MDX. If I run this code and look at my log, I see in the log the weight of an accurate MDX is 4451. So that is the value that it pulled from the dataset and put into this macro variable MDX_weight. You'll notice there's a few extra blank spaces here that we didn't ask for. That has to do with the way that SAS converts numbers into character values for storing them into a macro variable. But we have a little bonus. What happens if you add the keyword trimmed at the end of the into clause? Let's try that. Select weight into MDX_weight trimmed. If we run that, it will remove those leading spaces and we'll have just the weight of an accurate MDX is 4451. So the way we did it first, it actually stores the leading spaces as part of the macro variable value. When we use the trimmed keyword, then those spaces are trimmed off before it's stored in the macro variable. Now that we've reviewed the basics of macro processing, and we've discussed how to create macro variables, including at runtime using the call simplex routine or PROC SQL, we're ready to actually dig into some macro variable lists. First of all, there are actually two different ways to construct macro variable lists. These provide similar functionality, but a slightly different approach with each, and we'll discuss both. The two types are sometimes referred to as a horizontal macro variable list and a vertical macro variable list. A horizontal macro variable list consists of a list of values all stored in a single macro variable. For example, let's say we wanted to store these three values. These are the unique values of the variable origin from the dataset sashelp.cars, the vehicle origin, Asia, Europe, and USA. Let's say we wanted to store those three values in a single macro variable. This would be a way to represent them as a horizontal macro variable list, Asia space Europe space USA. Now you'll notice I'm using a %let statement to create the list here, and I'm calling it origin underscore list. However, our goal is to create this dynamically at runtime, not using a %let statement. But just to show you how the list it would look, I'm just representing it here with a %let statement. You do have to give some thought to what you want to put between each value. The whole point of storing these values in a list is because we're going to do something with this list, and we're going to need to be able to parse it apart again later. In order to do that, we need to know what delimiter we can use to separate the values later. You can use a space, but if you think your data values might contain a space, then it might be better to use something else. Oftentimes we'll use punctuation marks like commas, slashes, or even the tilde, which is what I've used here. So here's a horizontal macro variable list with the values separated by tilde. A vertical macro list works differently in that each value is stored in a separate macro variable, but the names of the macro variables are structured such that they all have the same prefix and then a sequential number afterwards. So for example, if we have these three values, Asia, Europe, and USA, and we wanted to place them in a vertical macro variable list, then we would create a macro variable called origin1, which would contain the value Asia, origin2 would contain the value Europe, and origin3 would contain the value USA. Again, I'm showing you these with %let statements, but that's not how we want to create them, because this is hard-coded. We want these values to come from our data, so that we aren't hard-coding these values in our program, but they're determined at runtime based on what happens to be in the dataset. That's where we're going with this. So this is just two different ways of representing the same set of values in a macro variable list, horizontal or vertical. Let's talk about how we can actually create one of these macro variable lists at runtime using our data. First, we will do it using PROC SQL. This is similar to the syntax that we just talked about in the previous exercise. However, we have a new clause here, which is this separated by language. So here we're going to take the distinct values of the variable origin, that's one of the variables on sashelp.cars, into a macro variable, that's what this colon means again, into colon origin underscore list, separated by the tilde character. That will take all of the values that are returned and it will string them out in a single macro variable separated by tildes. And you'll notice I used the select distinct keyword here because there are many records in sashelp.cars, about 400 I think, and each of these values of origin is repeated many times. We only want one copy of each unique value in our list that we're going to use for later processing. So we say select distinct origin. There are three distinct values in there. We concatenate them into a single macro variable separated by tildes. And then it's also helpful to know how many values are in that macro variable list. Because usually we're going to do some processing with this later, and oftentimes it's going to be in a loop. We may loop through this macro variable list and do something with each item from the list. In order to do that, it's helpful to know how many items are in the list so that we can control our loop. We could, of course, count those items later, but the information is readily accessible now, so we're going to grab it now. anytime you run a SQL query in PROC SQL, it creates an automatic macro variable called SQLOBS. And that macro variable contains a number representing the number of results that the last query returned. So we can take that value and store it in a macro variable of our own. I called it num origins here, the number of origins that there are. So I said %let num origins equals amper SQLOBS. I don't want to leave it in this macro variable SQLOBS because that might get overwritten later by PROC SQL if we should happen to call it again in our program. That's why I'm storing it in num origins, so I know I have a separate copy that I can use later. Now you might be wondering, how can I do this with a %let statement? Didn't I just get through saying all this stuff about how %let happens during macro processing and it's too early? Well, yes, that's true. However, what we need to understand is that when we submit SAS code, it's processed step by step. So in other words, one step, one data step or one PROC step is submitted, run through the macro processor, compiled, and executed, and then we go to the next step. In the case of PROC SQL, it's a bit of a special case. PROC SQL automatically executes as soon as you reach the end of a select statement. It's just the way that it works. So as soon as this semicolon at the end of the select statement is hit, then this code is submitted. It's run past the macro processor. Of course, there's no macro language in there. It's compiled and executed, and that query happens. And at that time, this macro variable SQLOBS is created. Then the next bit of code is run through the whole process, and that's this %let statement. Well, %let is caught by the macro processor, and it goes out and checks the symbol table for a variable called SQLOBS, which exists because that was created during the previous step. Okay, so we take that value, which in this case is going to be 3, and put it into a new macro variable called num origins. So what we end up with is two macro variables. One called origin list that contains this string, Asia tilde Europe tilde USA, and another macro variable called num origins that contains a 3. For our third exercise, we're going to create one of these horizontal macro variable lists using PROC SQL. This time we'll use the SAS help.class dataset, and we're going to get the names of all the students separated by spaces into a macro variable list called student_list. And we're also going to grab the number of students and put it in a macro variable called num_students. Here's the code we're given. All we need to do is complete the select statement and then add a %let statement here at the bottom to get the number of students. Let's flip over to our SAS session. Here we have exercise 3 ready to go. So we need to complete the select statement. And what is it that we need to select? We're going to select, well, we know the variable is called name, and we only want distinct values. Now, it just so happens with this particular data set, there's only one row per student, so we technically don't need to say distinct because there are only distinct values. However, just to be thorough, we'll say select distinct name, because what if we get a duplicate record later? Select distinct name into, and we're going to create a macro variable called student list, separated by, and I want them separated by a space, so I put a space in quote marks. Select distinct name into student list separated by space from sashelp.class. That should create my student list macro variable. I also want to know how many items did I just put in that macro variable. Let's do %let, and we'll create a new macro variable called num students equals, and then we will grab the value of the existing macro variable, SQLOBS. Okay, we run this code, we check our log, and I have a little diagnostic code here at the bottom again to show us the values of those macro variables. So we had 19 is in num students, and then the student list macro variable contains Alfred space, Alice space, Barbara space, and so on. And it runs through all the students' names all the way through William. Now we have a little bonus here. Use a delimiter character other than a space so that we could still distinguish individual names even if some contain spaces. Okay, let's try another character. You can pick whatever you want. Let's try a slash. I'll change that space to a slash, run the code, and now I get a new list of the 19 students where the names are separated by slashes. Now that we've created a horizontal macro variable list using PROC SQL, let's try creating a vertical macro variable list. The syntax is similar, except that we name more than one macro variable in our into clause. So you'll notice here we have select distinct origin into, colon, origin1, and then a hyphen. Now this hyphen tells SAS that origin1 is the beginning of an entire range of macro variables. There was a time in the past where you needed to give an upper bound to that range. For example, you might have said origin1 dash origin3. Or if you didn't know how many you were going to need in advance, you could say origin1 dash origin999, for example, and SAS would just use as many macro variables as it needed. However, a few versions ago, they made it so that you can simply say origin1 dash, and it will create as many as it needs. So if there are 3 distinct values of origin in sashelp.cars, it will create origin1, origin2, and origin3. We don't need to supply the upper bound. I also included the order by clause, which is optional, but if you want the macro variable list to be in a certain order, then you can use an order by clause to accomplish that. So in this case, they'll be alphabetical by origin. So the 3 values will be origin1 will be Asia, origin2 will be Europe, and origin3 will be USA. And then again, we have a %let statement just like before to get the number of items that we put into the list. Because again, when we get to some applications of these macro variable lists, we're going to most likely want to loop through this list, and we'll need to know how many items are in the list. Here are our resulting values from this code. We end up creating 4 macro variables in this case, origin1, origin2, and origin3 with those 3 values, and then num origins containing a 3. Our 4th exercise will be to create a vertical macro variable list using PROC SQL. And this is going to be just like exercise 3. We're going to get the names of the students from sashelp.class, but this time we're going to put them in separate macro variables, student 1 through student 19. And of course, we'll also create a macro variable called num students that tells us how many students are in our list. So let's slip over to our SAS session here. Here is the code for exercise 4. We have a PROC SQL statement, select, and we need to complete this select statement. Okay, I want to get the names of the students. The variable is name, but I only want distinct values, so select distinct name. And where do I want to put it into? I want to put it into a macro variable called student1 through whatever. I don't need to give an upper bound. We'll just say student1 dash, however many it needs, from sashelp.class, and then we will add a %let num students equals, and we'll grab that macro variable SQLobs, grab that value and put it into a new macro variable called num students. And then we have some code down here that will print out the values of these macro variables so we can verify that this was done correctly. I didn't print all 19 for lack of space, so we have the first 3 and the last 3. Let's run this code. Check our log. PROC SQL ran, and here is this output down here, number of students 19, and we notice that student 1, that was this macro variable, amper student 1, has a value of Alfred. Ampersand student 2 has a value of Alice. Student 3 has a value of Barbara, and so on down the line all the way to student 19, which contains the value William. So the 19 names of the students were put into 19 separate macro variables, but the names of the variables are structured student 1 through student 19. That's what makes this a vertical macro variable list. We've created macro variable lists using PROC SQL, both horizontal and vertical lists. Now we're going to talk about creating those same types of lists using the data step. Using the data step is a little bit more complex than using PROC SQL, but there are times when it can be advantageous because you have access to the full power and flexibility of the data step. First, let's talk about how to create a horizontal macro variable list in a data step. I have this code split across 2 slides. This is step 1. And this step is optional, but I'm assuming that we want only a list of distinct values. So since we don't have the convenience of the distinct keyword like we do in PROC SQL, we can use PROC sort to get just the unique values of origin. That's the variable that we're going to put into our macro variable list in this case. So we do a quick PROC sort, data equals sashelp.cars, out equals, and I created a new data set called unique origins, and I only kept the variable origin. And here's the key. I used the keyword nodup_key, which eliminates duplicate key values. In this case, the key is origin. That's our by variable. So this will create a data set that has just the variable origin and just 3 rows with those 3 values of origin, which are Asia, Europe, and USA. Once we've done this, now we can use a data step to build our macro variable list. And we're simply going to step through this data set and build the list piece by piece. So we start with data null because we're not really interested in creating an output data set here. We have a set statement, unique origins, that's the data set that we just created in PROC sort, end equals EOF. EOF is just a variable name that I made up, but the end equals option on the set statement will set this variable EOF to true only once the last record has been read from unique origins. It'll be false until that point in time. We'll need that in a little bit. This length statement simply declares that a new variable called origin list is being created with a length of 200. Now this is not a macro variable. This is a data set variable, origin list. It also appears on this retain statement because we're going to build this origin list across multiple iterations of the data step as we read in values from the unique origins data set. So we need to be able to retain the values across iterations of the data step. That's why we have this retain statement here. Then we have the workhorse of this data step, an assignment statement, origin list equals, and on the right-hand side of the equals, we have a call to the catx function. Now, for those who aren't familiar with the catx function, it simply concatenates strings, but it inserts a delimiter, and that's the first argument to the function, the delimiter, in this case, tilde. So the catx function will take these other arguments, origin list and origin, it will strip them, that is, removing trailing and leading blanks, insert this delimiter in between and concatenate them. Now, the first time through the loop here, the first time through the data step when we read in the first record, origin underscore list is missing. It's blank. There's nothing in it. Origin has the first value that we read in from the data set, which was Asia. So when we call catx, if we give it a missing string, it will not insert a delimiter. It's smart enough to not do that, which is great. It makes it very convenient. So what we'll end up with is catx of missing and Asia will just be Asia. So the first time through, origin list equals Asia. Then we have this if EOF, then do. Well, EOF is false because we haven't read the last record yet. Since EOF is false, we don't do any of this stuff in the do block down here. And we just we finished our trip through the data step, and now we loop back to the top and read another record. We read the second record from unique origins, which is Europe. And now origin list equals catx of origin list, which has Asia from before. And remember, it's still there because we used a retain statement. Asia, the tilde gets inserted as a delimiter, and Europe is the new value we just read in. So now origin list will have Asia tilde Europe. We're still not at the end of the data set, so this is false. We go back to the top and read the third and final record from unique origins, which is going to have a value of USA. So now origin list equals catx of, and origin list still has Asia tilde Europe in it, and now we got another tilde as a delimiter, and then the value USA. So now we're going to have Asia tilde Europe tilde USA in a data step variable called origin list. We haven't created a macro variable yet. This is just a data step variable. But now EOF is true. We are at the end of the file. And since we're at the end of the file, we are going to do these, execute these two statements that are in the do loop, the do block, I should say. So we have a call simputx. Remember, call simputx is what we use to create macro variables during a data step execution. We're going to create a macro variable called origin list, and what we're going to put in it is the value of the data step variable origin list. That's the variable we just created. So this is a little confusing because these have the same name, but these are two different things. We're creating a macro variable called origin list, and we're putting in it the value of the data step variable called origin list. Then we're going to create another macro variable called num_origins, and into it we're going to put the value _n_. _n_ is an automatic variable that is created for us by the data step, and it simply counts the number of iterations that the data step has executed, which is, you could typically think of as a counter of which record we're on, assuming we're just reading in one record per loop. So at this point in time, _n_ is 3 because we're on our third trip through the implied loop of the data step. So the number 3 is going to get stored in num_origins. So we've created two macro variables here, one called origin list, which has Asia tilde Europe tilde USA, and one called num_origins, which has a 3 in it. For exercise 5, we're going to create a horizontal macro variable list using a data step. Once again, we're going to deal with the SAS help.class dataset, and we're going to take the names of all the students separated by tildes and put them into a single macro variable called student list, and then we'll also store the number of students in another macro variable called num_students. And we can skip the PROC sort step for this exercise because we know the student names are unique. There's only one record per student name in the data set, so we don't need to worry about removing the duplicates. So here's the code that we're going to be given. Most of the data step is already put here for you. We just have to add a few things. So we have our set statement, our length and retain statements, and we have the beginnings of this assignment statement, student_list equals, and now we need to add some logic to concatenate or append the current name to student list so that we can build this string piece by piece. And then we're also going to need to add these two call simputx statements inside of this if-then block at the bottom. So let's go over to SAS, and we will do that. Exercise 5. All right, so here we have our assignment statement, student list equals. Now, what I want to do is take the existing value of student list, which is going to be blank the first time through, and concatenate the current student name onto it. And our delimiter is going to be tilde, so I'm going to put a tilde as our delimiter. That's the first argument to catx is always the delimiter. Then the things that we want to concatenate. Well, we've got student list, and we've got a name, the variable name, which comes from this SAS help.class dataset. So there's our assignment statement. When we get to the end, we're going to have to create a couple of macro variables using call simputx statements. So let's do that. Call simputx. I'm going to create a macro variable called student list, and I'm going to put in there the value of this, the data step variable called student list. I'm going to put that in there. But I don't want to do this until the end of the data set because I want to wait till I have the whole list right before I go sticking it in a macro variable. And then I also want to know how many students there were on the list. So num students, and that's just going to be _n_. And by the way, even though _n_ is a numeric variable, call simputx will automatically convert it to character for us using a best 12 format. So unless you need to use a different format, you can just let simputx do the conversion for you. And then I have some code here at the bottom that will make sure these macro variables have the values that we think they should have. Let's run this code. And let's look at our log. And we have number of students is 19, and the student list Alfred, tilde, Alice, tilde, Barbara, and so on, all the way through William. So we created a horizontal macro variable list, this time using a data step, but we got the exact same results that we did a couple of exercises ago using PROC SQL. Creating a vertical macro variable list in the data step is actually much more straightforward than creating a horizontal macro variable list was. We don't have to do all this bookkeeping to retain information across loops of the data step because we're already looping through one value at a time, and with a vertical macro variable list, it makes it easy to put out a single macro variable each time through the loop. Once again, we start with a proc sort in order to get only the distinct values of the variable origin. In this case, those will be the three values, Asia, Europe, and USA, just like before. And then we have a simple data step here that creates our vertical macro variable list. Again, we have a set statement with the end equals option in effect. Then we have a call SYNPUTX. This first call SYNPUTX will execute every single time through the data step. For every record that we read from unique origins, we'll write out one macro variable. So you'll notice the first argument to call SYNPUTX is actually a call to the cat_s function. Cat_s also does string concatenation, but unlike cat_x, it doesn't insert any delimiters, which is fine because we don't need that here. All we want to do is take the word origin and append the numeric value representing the current record. So _n_ will be 1 the first time through the loop. So what cat_s will return is simply the string origin1. So we'll create a macro variable called origin1. That's what we're building here, is the name of the macro variable. Then the second argument to call SYNPUTX is the value that we want to put into that macro variable. In this case, it's the value of the data step variable origin, which the first time through contains Asia. So origin1 will get Asia. If EOF, that's not true. It's not true the first time through the loop. So we go back around and read a second record. Second record contains the origin Europe. We call SYNPUTX again. This time the macro variable name that we create is origin2 because _n_ has a value of 2. And we create a macro variable called origin2, and into that macro variable we place the value of the variable origin. That's Europe. So origin2 has Europe in it. EOF is still not true, so we go back for the third and final time. We create the macro variable origin3 and put USA in there. Now EOF is true, so we execute this final call SYNPUTX, and we create the macro variable num_origins, and we place into it a 3, which is the current value of _n_. So at the end of this, just like we did when we created the vertical macro variable list before using PROC SQL, we will have 4 macro variables, origin1, origin2, and origin3, containing those 3 values, and then num_origins containing a 3. So for our 6th exercise, we're going to create a vertical macro variable list using the data step with the names of the students from sashelp.class. And again, the student names are unique, so we don't need to worry about using proc sort to remove the duplicates first. We'll just go straight to our data step. Here's our set statement. We need to add 2 call SYNPUTX statements to create the macro variables. The first call SYNPUTX is going to create the student1 through student n macro variables, and then the second one will only execute once and will create num students. So let's go to our SAS session, and we will work on this exercise, number 6. Okay, so we need a call SYNPUTX, and I want to create a macro variable, and I want my macro variable called student and then a number. So I'm going to concatenate the word student, and then I'm going to use the convenient automatic variable _n_ to get the number. And remember, the cat functions will automatically convert numeric values to character values using the best 12 format. And cat_s will also automatically strip leading and trailing blanks from all of its arguments. If you don't want those stripped, you use the plain old cat function. But here we're using cat_s. So it strips trailing and leading blanks from _n_, and we end up with just student1 with no spaces in it. So that's the name of our macro variable. And then what do I want to put in there? Well, I just want to put the name of the student. Okay, so that's my first call simputx. Now when I get to the end of the data set, I've read in the last record from sashelp.class, I'm going to call simputx one more time, and this time I'm going to create a macro variable called numStudents. And into that macro variable I'm going to place underscore n underscore, which is going to be 3 in this case because there are going to be, I'm sorry, not 3, 19. I'm still thinking of the vehicle origins. 19 students. So underscore n underscore is going to be 19. That will get put into numStudents. Let's run this SAS code, and we have some put statements down here to put things to the log so we can see what happened. Here's our log, and we can verify that yes, we got numStudents is 19, and we have variables student 1 has Alfred, student 2 has Alice, and so on, just like before with PROC SQL. So we have 2 different ways to create macro variable lists, both horizontal and vertical, using either the data step or using PROC SQL. So we've been talking a lot about how to create macro variable lists, but you've probably been wondering all this time, what are we actually going to do with these things? Why are these useful, and why should I care about how to create them? Well, now we're going to talk about some simple applications of macro variable lists, although the potential for these things goes far beyond what we're going to talk about today. I find these things extremely useful, and I use them almost every day in my regular work. So first, let's talk about how we actually use a horizontal macro variable list. How do we actually access the individual elements? Well, there are several ways, but what I typically do is use the %scan macro function. The %scan macro function lets us parse the list and pluck off a specific element based on knowing which number of element we want. So the first argument to the %scan function is simply a string that you want to parse. In this case, it's going to be our horizontal macro variable list, which is all stored in one macro variable. Let's suppose it's called origin list. So here we have ampersand origin list, which is a reference to that macro variable. The second argument to %scan is the number of the word that you wish to return. Do you want the first word, the second word, etc.? And then the third argument is the delimiter that it's supposed to use. So obviously this is going to need to match the delimiter that you used when you built the horizontal macro variable list in the first place. So, for example, if I call %scan ampersand origin list, comma 1, I want the first word, comma tilde, the first word when you use tildes to define words, well, origin list has Asia, tilde, Europe, tilde, USA. So when you use the tilde as a delimiter, then the first word is just Asia. So when the macro processor sees %scan origin list 1 tilde, it's going to resolve that to simply Asia. When it sees %scan origin list 2 tilde, it's going to resolve that to Europe. That's going to happen during macro processing, meaning that all that the SAS is ever going to see is just the word Asia or the word Europe or the word USA. Typically, the way we're going to use these elements is inside of a macro do loop. So you see here we have %do, I equals, I is another macro variable that's being created to use as a loop counter. I equals 1 to numOrigins. NumOrigins is the variable, the macro variable that we created that contains the number of items in our list. In this case, 3. And remember, we created that earlier so that we would know how many items are in the list, and we wouldn't have to go and count it later. So now we're going to use that. I goes from 1 to numOrigins, and inside our %do macro loop, we have a %put. So we're just writing some stuff to the log so we can see how this works. %put item ampersand I, that's our loop counter here, 1, 2, 3. And then we have a %scan, but you'll notice that the second argument to %scan is not a hard-coded number like it was up above. Rather, it's a reference to the macro variable, I, which was our loop counter, ampersand I. So we're going to take the ith item from the origin list, which was our macro variable list. So the first time through the loop, it's the first item. The second time through the loop, it's the second item, and so on. And what we end up with is this in our log. Item 1, Asia. Item 2, Europe. Item 3, USA. So we built this macro variable list dynamically from the data without hard coding in any of these values to our data, and now we've read them back out. So for exercise number 7, we're going to do something with a horizontal macro variable list. Well, first we're going to create the list, and then we're going to use it. So the code here, I've got it split across 2 slides. We're going to use a new data set we haven't played with yet, sashelp.stocks, and our task is to create a separate plot in a separate file for each stock in the data set. And of course, we're going to do that without directly referring to any specific values. So because we're going to use a macro do loop, we have to do this inside of a macro definition. You can't do %do out in open code. We need it inside of a macro definition. So first we define a macro. This one's called graph stocks. And then we have a SQL step, and this part's given to you as part of the exercise. We have a SQL step that creates the horizontal macro variable list by taking the distinct values of the variable stock, and that has values like IBM, Intel, and Microsoft. It's the name of a company. Takes the distinct values of stock, puts them into a macro variable called stock list, separated by tilde. So that's our horizontal macro variable list. And then we also create num stocks, which gives us the number of items in the list. Now your task for exercise 7 is to fix up this code here to replace the hard-coded values where it says IBM using the %scan function to get the current stock from the stock list macro variable. What we want this to do is we want this do loop to plot one time for every value of stock that was in our data set, but without us having to specifically refer to those values, right? I don't want to tell SAS, first plot the IBM stock, then plot the Intel stock, then plot the Microsoft stock, because what if later I get a new data set and it has a different stock in it? I'd have to change my code, and I don't want to do that. I want to write dynamic code that's driven by the data. I have a do loop here, %do, and inside my do loop, you'll notice I have a proc sgplot. We're not going to spend time talking about how sgplot works, but that's what creates the plot. And it's wrapped in ODS PDF file and ODS PDF close. That opens and closes a PDF file. So we're going to create a separate PDF file for each value of stock. That's why we can't simply use a by statement in our proc sgplot. And remember that the macro language actually generates SAS code. So what's going on here behind the scenes inside this %do loop is all these statements, the ODS statements and the proc sgplot, are being generated once for every value of stock from our data set. So let's switch over to SAS and see if we can get this working. Okay, so I need to replace the hard-coded values of IBM with the %scan function. So I'm going to call the file by the name of the stock.pdf. So %scan. Now, what's the first argument to %scan is the thing that I want to parse. Well, that's this macro variable that I just created called stock list. I have to make sure to put an ampersand in front of it because I'm referring to a macro variable. That was created up here in the proc SQL step. The next thing is, which item do I want from stock list? Well, I'm in a loop, and on the ith time through the loop, I want item I. And what's my delimiter? Tilde. So let's close the %scan function. .pdf. So when the macro processor processes this, it will replace everything from the % through the closed parenthesis. It will resolve that to IBM or Intel or Microsoft, depending on which time through the loop. And I'm also going to put this, I just copied that little bit of code. I'm going to put it right here as well. We can get rid of these comments now. And this one too. Okay, so now I have a do loop. So each time I go through the loop, I'm going to open a file with the name of the value of stock that I pulled from my macro variable list. That's the name of the file, .pdf. Then I do proc sgplot where stock is equal to, and again, this is going to be IBM or Intel or Microsoft. These values are going to come from the data set sashelp.stocks. You'll notice in this code now, not once do I refer to a specific value from the data. This is all driven by the data. Let's run this code. Here's the end of the macro definition, and this actually calls the macro. So we run this code, and yep, we get 3 different plots. And they went to 3 different PDF files. So you can see we have IBM.pdf, we have Microsoft.pdf, and we have Intel.pdf. So we got 3 separate PDF files. And we can look, here's our SAS log, and you'll notice we called PROC SQL 1, 2, 3 times, writing to different files. So Microsoft.pdf, Intel.pdf, and so on. And if we were to look out in our file explorer, we would see those 3 PDF files. But the amazing thing about this is, if the data set changes and we add more companies into this stocks data set, we don't have to change the code. We just run it again and we would get a separate PDF for whatever companies happen to be in that data set. That's what makes this so powerful. Now let's talk about using vertical macro variable lists. This is where the syntax gets to be a little bit more challenging. If I want to access the macro variable origin 1, that's the first item in my list, I just say ampersand origin 1, and that's going to resolve to Asia. If I say ampersand origin 2, it resolves to Europe, and ampersand origin 3 resolves to USA. Now the trick is, how am I going to use this in a loop? Because I can't say amper origin amper I. If I were to say that, the macro processor will interpret that as 2 macro variable references. It will think that I'm referring to a macro variable called origin and then referring to a macro variable called I. Well, there is no macro variable called origin. I have macro variables called origin 1, origin 2, and origin 3, but not just origin. So this is going to fail. The way that we get around this is with this syntax, a double ampersand. Ampersand, ampersand, origin, ampersand, I. Now, why does that work? Well, here's the way it works. When the macro processor parses this, the first token that it sees is ampersand, ampersand. Ampersand, ampersand always resolves to ampersand. You just have to remember that. Okay, so the macro processor resolves 2 ampersands to 1 ampersand. After that, it sees the word origin. That's not a macro keyword. That's just text as far as the macro processor is concerned. So it ignores it and passes it along. Okay, so the 2 ampersands became an ampersand. Origin stays as origin. Now we have ampersand I. That is a reference to the macro variable I. And if we're assuming, I'm assuming we're in a do loop here, and I is our loop counter, the first time through the loop, ampersand I resolves to 1. So amper, amper, origin, amper, I resolves to amper, origin, 1. Remember, at the beginning of this talk, we talked about when the macro processor finishes, it rescans whatever it produced to see if there are more macro language elements. So this gets rescanned, and there's still an ampersand. This is now interpreted as another macro variable reference. So on the second pass, amper, origin, 1, that's a macro variable reference to a macro variable called origin 1, and that resolves to Asia. So it takes 2 passes, but amper, amper, origin, amper, I resolves to Asia when I is 1. When I is 2, the second time through our loop, then amper, amper, origin, amper, I resolves to amper, origin 2, which resolves to Europe. So we can use it in a do loop like this. Percent do, I equals 1 to num origins. That's the number of items in the list. In this case, 3. Percent put item amper I, and now we have this amper, amper, origin, amper I. And this will run 3 times, and the first time through, this will resolve to Asia, the second time Europe, and the third time USA. So for exercise 8, we're going to use a vertical macro variable list in a macro do loop. And this time we're going to take the data set sashelp.cars, and we're going to split it into separate data sets for each unique value of origin. But But of course, we're not going to hard code those values. It's going to be data driven. That's why we're doing all this. So here's the code we're given. Again, we have a macro because we're doing %do. We need it to be inside a macro definition. This is our macro definition. Split data is the name of our macro. Here's the PROC SQL step that creates the vertical macro variable list. It uses the sashelp.cars dataset and puts the distinct values of the variable origin into a series of macro variables, origin 1, origin 2, origin 3. And of course, we also create num origins, which will have a 3 in it, the number of observations that were returned by this query. That's the first page. We continue the macro definition. Our task is to replace these hard-coded values that say Asia with a reference to our vertical macro variable list so that this loop will work and create a separate data set for each origin. Let's go over to our SAS session here and do exercise number 8. Here's our macro do loop. Got the PROC SQL step that creates the vertical macro variable list. Do I equals 1 to num origins. Data, so we're going to build a data step. Data cars underscore Asia. Well, actually, we don't want to call the data set cars underscore Asia. We want to call it cars underscore, and then we want to refer to the ith item from our macro variable list, which is going to be origin 1, origin 2, origin 3. So amper origin amper I. Cars underscore amper origin amper I. That will resolve to cars underscore Asia the first time through the loop. Where origin equals amper origin amper I. Okay. All right, so now we should have a do loop that will build this data step. So when I is 1, we'll have data cars underscore Asia, set sashelp.cars, where origin is Asia. When I is 2, it'll be cars Europe. When I is 3, it'll be cars USA. Let's run this. Okay, and we see we created cars Asia, cars Europe, and cars USA. And if we go over here and look at our data sets, we have those 3 data sets, cars Asia, cars Europe, and cars USA. But we never once in our code referred to any of those specific values. So again, if the data set changes later, we just rerun the code and we'll get one data set for each value of that variable origin. Just for fun, let's turn on the imprint option and run this again. So I want to show you the actual SAS code that gets generated, because remember, the macro language is just a typewriter that generates SAS code for us. So let's run this part of the code again and go to the log, and now we can actually see here. Here's the data step that was generated. Data cars underscore Asia, set sashelp.cars where origin equals Asia. So just the records where origin is Asia were put into this data set. Then we have down here data cars Europe, set sashelp.cars where origin equals Europe. And then we have one for USA. So basically, we used the macro language to generate this data step repeatedly for every single value of origin, regardless of how many values of origin they happen to be or what they are. To wrap up what we've talked about here, I think hopefully you've seen by now that macro variable lists can be extremely powerful. They help us make code that is dynamic and data-driven. Code that we don't have to constantly change and update every time the data changes. I don't know about you, but I don't like to have to keep changing my code. I like to write my code once and do my future self a favor by writing code that won't require future changes if I can avoid it. I like to avoid hard coding because hard coding makes my code more difficult to reuse and more difficult to maintain. And I like to have code that adapts to changes in the data or changes in my computing environment. And that's what macro variable lists allow us to do. Hopefully, you've found something useful here that you can use in your work. if you would like, there is a paper that goes along with this hands-on workshop, and it's part of the SAS Global Forum 2020 conference proceedings, and you can find that at sasglobalforum.com. And there are also other papers out there on the internet. You might check lexjansen.com, which is an excellent resource for SAS programmers, because there are many, many user group papers from over the years out there. And you can find other information about macro variable lists. You can also refer to the book I mentioned earlier, which is by Art Carpenter, Carpenter's Complete Guide to the Macro Language, 3rd edition. He has extensive treatment of macro variable lists in his book. And you can feel free to contact me at this email address shown on your screen. I'd be happy to answer questions or interact with you further about this topic. Sorry we weren't able to meet personally at SAS Global Forum this year, but I do hope I will get a chance to meet with you at a future conference. Thanks.